We are going to start. So here's the plan for today. Here's what I want to do. I want to do a quick introduction. I want to introduce you to cycles. I want to introduce you to power cycles and heat transfer cycles. And I want to talk about the Carnot cycle, which will then lead us, because the Carnot cycle is the ideal case of the cycle. And that will lead us into you guys taking over and talking about your cycles. Are we good? So we should start. So the first real engine was a steam engine invented by Newcomen in 1712. It was a terrible engine. It blew up. It was extremely inefficient, right? Then 50 years later, after terrible, terrible consequences, Watt, which is also the unit of power, right, produced a steam engine that was a little bit better. In terms of not blowing up as much, but again, extremely inefficient. 60 years later, one whole generation later, in 1820s, Carnot worked extensively on engines to improve efficiency. And in 1824, he came up with the ideal engine concept that he called, can someone take a wild guess what he called it? No. Okay. Now, let me briefly, quickly talk to you guys about engines. And in order to talk to you about engines, let me start by saying that all engines are based on compression expansion cycles, right? Which means I will have basically a piston and cylinder contraptions. And the work done, as we have been discussing, will be given by PDV. And we will concentrate on reversible processes. What do I know about real life? There are no processes that are completely reversible. So, in general, we have to divide our study into two parts. One called theoretical thermodynamics, and the other one called applied thermodynamics. Theoretical thermodynamics deals with properties of matter and measurements. Applied thermodynamics deals with solutions to practical problems. Theoretical thermodynamics says all processes are reversible, are generally reversible. We find the solution, then we try to figure out how wrong we were. Applied thermodynamics is what engineers are concerned with. So in the theoretical thermodynamics, everything is ideal. There's no friction, there's no drag, there's, absolutely perfect conditions, which, as we know, do not exist, right? And applied is actually practical. So we, in this class, will be dealing with the theoretical. So, choices in thermodynamics. Real life is messy. How does thermodynamics deal with this mess? So we deal with it in thermodynamics by following certain rules. Number one, assume all processes are reversible. Number two, find answers. Number three, find how wrong you were. And number four, make corrections. To find approximately correct answers. Good? That is how thermodynamics, classical thermodynamics works. Nowadays, we don't do these corrections by hand. We do a lot of computation.